Hi, we are going to discuss how to write compositions of functions and also how to write, how to find their domains. The first thing we're going to need to do is understand what composition of the functions is. So when you have it written like this, another way this sometimes is going to be written is f of g of 3. And what you need to do here is you need to evaluate g of 3, and then g of 3 will become the input. The output of g of 3 is going to become the input for function f. So g of 3 is 9 minus 2, which is going to give us 7. And then f of 7 is going to be 7 plus 1, which is going to be 8. Right? So then this here is what the answer is going to be. The answer is 8. So if you try to do it the other way around, now this means that you want to do g of f of 3. That means you're going to have to find f of 3 first and then substitute that value into g. F of 3 is going to be 4. So g of 4 is going to be 4 squared minus 2, which is 16 minus 2, that's 14. So that will be the answer for that one. So this is the process that happens there. Basically what you have is you have one function that is going to be that's going to take the input value, that's going to process that value, give its own output, and then the output of that is going to become the input of the other function, and then you use that and to finalize the answer. So let's try to do it algebraically and see how this works. One thing that you have to keep in mind, both of these functions, their domain is going to be all real numbers. I'm going to write it here symbolically because it does make a difference. So when you write f of g, what you're going to do is you're going to substitute function g, algebraic expression for function g, into function f. And the way it's going to be done, it's going to be f of x equals, here instead of x, so every place where x may occur, you're going to replace it with x squared minus 2, which is g. And then you're going to have plus 1. And that whole thing is going to simplify to x squared minus 1. This is going to be the algebraic answer for this. As you already understand, when you reverse it, it's going to give you probably a different answer. Oh, and the domain here is going to be all real numbers, by the way. So when you do g of f, you do exactly the opposite. You take function g, you take f and put it inside of g, replace x with that. That means that, by the way, I missed the symbol. This should say f of g of x. So g of f of x is going to be, we're going to have x plus 1, that's going to replace x in function g, and everything else stays the same. That means we're going to have x squared minus plus 2x plus 1 minus 2, which is going to give us x squared plus 2x minus 1. That is the answer for this one. The domain here is also can be all real numbers. There are no restrictions for x anywhere. I'm going to write it this way. Let's take a look at something like this. First and foremost, we do need to look at the functions that we are going to use and see what's going to be the domain of each one of them. So function f, its domain is x plus, is going to be all real numbers. For function g, you should be able to see that the domain is going to be x is greater than or equal to -1. So when you write f of g, you put g inside of f. So this here, this quantity square root, is going to replace this x, which means it's going to be square root of x plus 1 and then minus 2. This is actually the answer. So what is the domain here? The domain here is going to be determined by, well, it's pretty much the same thing that you have here in this case. So x has to be greater than or equal to -1, so from -1 to infinity. What about when we reverse this? So then you're going to substitute f of x inside of g. So x minus 2 is going to replace this x here. It's going to be square root of x minus 2 and then plus 1. And that's going to give us square root of x minus 1. So when you look at this function here, this alone, its domain is going to be x has to be greater than or equal to 1. Right? This function here wanted us to have x to be greater than or equal to -1, but we have to consider them together. This is a compound inequality with AND. And what we're going to get from here is that for domain, x has to be greater than 1, because it's going to be the most restricted of the two. So it's going to be from 1 to infinity. Another example, these two functions. So when you write first, the domain here is going to be all real numbers. This here requires that x is less than or equal to 4. So when you do f of g, you take g, this, and substitute every x in function f with that. So that is going to be, in our case, square root of 4 minus x minus 2. So this one's pretty simple. You still have the same square root. This is going to be the same restriction. And the domain is going to be from -infinity to 4. The other way, so now you're going to take function f right there and substitute that inside of g, replacing x. It's going to be the square root, let me use a different color here, 4 minus, and x is going to be replaced with x minus 2. So that's going to give us 6 minus x. Square root of 6 minus x. Correct? So that one here is going to require that x is going to be less than or equal to 6. But the original restriction here told us that we need to have x to be less than or equal to 4. But here's what we're going to look at. When you do this, which function goes in first? The first function that goes in is function f. So the restriction for function f is important. The restriction for function f is non-existent, it's all real numbers. The restriction for function g is what matters then, but it's not going to matter that much, because remember how this process works. You take a value, if you're trying to do g of f, the first any value of x is going to go here, and then the result of that's going to be there. So as long as this is true, this is all we're going to care about, and this is actually going to be our answer here. So the domain here is going to be -infinity to 6. Have a couple more examples. Actually, a little bit more. So what do we have here? Let's try to see if we can understand this better now. F of x is this one function, that's a quadratic function, and its domain is going to be all real numbers. Here we want x to be less than or equal to 7. So depending on which function goes into what, it's going to make a difference. So here g goes into f, so the domain of g is going to matter. When you substitute that, you're going to do square root of x minus 7, because we're taking g and putting it inside of f, squared minus 2. That's going to give you x minus 7 minus 2, which is x minus 9. So when you look at this, you would think that it's looks like it's all real numbers, because there is no restriction here, it's a linear thing. But it's not correct, because g was the function that takes input from x, because it's the one where x goes first, and that one had restriction of x to be less than or equal to 7. So that means the domain here is going to be negative infinity to 7. What about g of f? Well, g of f, we're going to reverse that process, and we're going to, so because f here is the one that we're going to substitute in here, then f is the one whose domain we're going to need to remember when we get to the end of it. But the domain of f is all real numbers. So it's going to be square root of 7 minus, replace that with x squared minus 2. And that is going to give us square root of 9 minus x squared. So if we do the math here, we should understand that x here is going to be restricted from -3 to +3. Okay, and now we're going to remember that we wanted to be concerned with function f, but function f, its domain is all real numbers, so we don't have anything to worry about there. And this will be our domain, so the domain of this function is going to be from -3 to +3. Okay, last couple problems. So we have this example here. We have f going into g. So f, its domain is all real numbers. We don't really need to care about g. Let's go ahead and take a look at that. So we're taking this function and putting it here. It's going to be square root of x squared minus 2 plus 3, which is going to give us square root of x squared plus 1. That is it. And this function does not have any restriction for x, because x squared plus 1 will never be negative. And the function f that was going into g has no restriction. The domain is going to be all real numbers. Our last example. Yes, you can write a composition of a function going into itself, because when you write a composition, it's just one function going into another. There's no reason why you can't use the same one. So we should realize that x here cannot equal 1, right? Because you cannot divide by 0. And since that function goes into itself, this is going to be an important piece of information that we're going to have to use later. So you're substituting f of x into f of x. That's going to be 2 over x minus 1 minus 1. This is what happens when you substitute x here with the same function. So we need to get rid of this 3-tier fraction. We don't like them. So the most logical way to do that is multiply top and the bottom by x minus 1 to eliminate that we have the 3-tier fraction. So what are we getting here? 2 times x minus 1. The denominator is going to be, you multiply x minus 1 by this quantity, that's going to leave you with 2. Multiply x minus 1 by -1, you're going to get -1 times x minus 1. We don't really need to worry about the numerator because it does not impact this much, but the denominator is important. But let me rewrite the numerator as 2x minus 2. The denominator will be 2 minus x plus 1. So we have 2x minus 2 divided by 3 minus x. So this is what's going to happen here. This function here requires that x does not equal 3. And originally, when we were talking about this, the function that goes into the other function, which is f, cannot have x equal 1. So x cannot be 1 or 3. And the domain here will be from -infinity to 1, union 1 to 3, union 3 to infinity. So you have to be very, very careful when you're trying to find domains of composed functions, because you have to remember to consider the function that takes the value of x, the function that you put into the other function. That function's domain is going to often matter in the final answer. Okay, so I hope this helps.